for the poor image. Okay, so today is integration by parts. So let's say if we have u of x and v of x represent two functions. Okay, so we know that the derivative, we'll just call them u and v for short. Using the product rule is the first times the derivative of the second plus the second times the derivative of the first. Okay. Now v prime, actually if you integrate both,
d of dx?
Yep. Okay. So actually, should go one more step. Okay, so that means derivative with respect to x, u and v is equal to, u and your v prime, remember that's derivative of v with respect to x, plus your v times derivative of u with respect to x. Okay, so actually, let's say if you have dv dx equals dv prime, so that means your dv is equal to v prime dx. Derivative of u with respect to x is equal to u prime. That means du is equal to u prime dx. Okay. So what if we integrate both sides? So if we integrate both sides, that means uv equals the integral of u, and dv dx, actually if we left it like that, you know our v prime is dv dx, or we can make that v prime dx plus, where is it? The integral of, where is it? I'm trying to move around this thing. This thing is blocking my, boy, this is blurry. Let me move this out the way so this won't reflect on it. It's going to be reflecting some sunlight. Alright. Okay, so now here we have your, remember that's u prime, which you already know that's your du dx. That should be dv. Yep, that was dx. So we know with our du is equal to u prime dx. Actually, I should have left it like that. A little easier. Yeah, I'll just skip the middle step. It makes it more complicated. So u prime, and integrate both sides. That actually makes that u prime dx. There you go.
Why did you erase the v?
Oh, v is actually
So
just brought it to the front.
Oh, it's multiplied on the outside?
Yep, it's just multiplied, because all we're having is the derivative.
For the u as well.
Yep, if you want to factor out the u, you could, but you don't have to. Kind of depends on what it is. But if you left it on the inside or outside, it would still work.
So why is v on the outside?
Oh, the only reason I
V is
did
not
that,
on the outside for the other one.
well, could have. The only reason I did that was to separate it because our u prime dx is du. So you have UV minus,
You move it up.
oh. Okay, so your dV is V prime du, so we can just make that dV. Oh, equals. Plus the integral of V du, if you want to make it that way. And you can put it inside or out, doesn't really matter. Because sometimes your V will be a constant, sometimes it won't, so you can either put it in or out, you still get the same formula. All right, so if we subtract the integral of V du from both sides, you have the integral of u dv equals uv,
You move it up a little.
oh, sure, minus the integral of v du, which is actually your integration by parts. Formula. Okay. So for this one, probably the most confusing part is picking which part to be your u and which part to be your dv. And I'll show you what I mean in 1 second. So I'll leave that up for a few seconds in case anyone's still writing. All right. All right, so the choice for u and dv are very important. Okay, so a lot of times if you pick the wrong factor for u and the wrong one for dv, it can cause you a lot more work. So what we'll do is we'll use the acronym, I don't even know what that would spell, but LIATE. Okay, well, the L is for logarithms. The I is for inverse trig functions. Okay, the A is for algebraic expressions. Or just powers of x. The T is for trig functions. And the E is for exponential functions. So the higher up on the list your, I guess your factors would be, that's what you would make your U. Okay, so the more likely, oh, move that up some. Okay, so the higher on the list that your factor falls into, the more likely you should use that for your U. All right, make sure everyone's still writing. I'll leave this up here for a few seconds. All right. let's say, for example.
Could you actually put
Oh.
that up?
Oh, sure.
Okay, my bad.
All right. Okay, so let's say, for example, if you wanted to evaluate the integral of x e to the x dx. Okay, you want to remember your LIAT. Now you have a bunch of options that you could make for your u. You could have, let me see, just x e to the x dx. You can make your u equal x and your dv equal e to the x dx. Or you can make your u equal e to the x and your dv equal x dx. Or even if you wanted to, you can make your u equal 1 and your dv equal x e to the x dx. There are just tons of options. That's why you want to go with this one, because if you pick the wrong one, it will, and you'll see how quickly this can build up. It'll be a lot more work if you pick the u value that kind of drags on. All right, so using this acronym here, we don't have any logarithms, we don't have any inverse, but we do have algebraic functions. So we can make our u equal x. Okay, so you're going to use that first option. Okay, so our u is equal to x, which means our dv is equal to e to the x dx. Okay, so that's the first part, just finding our u and our dv. Okay, so from those two, we can actually find our du and our v. Okay, so those are the two we picked. Okay, so du is equal to dx. You just differentiate both sides. And our v is actually just our integral of dv. Which is the integral of e to the x dx. Okay, so the integral of e to the x dx is just e to the x. Bless you.
Do you want the plus c with that or no?
Nope, you don't have to put the plus c in yet. We actually add that at like the very end. All right, so any questions on this so far? All right. So we know the integral of u dv equals uv minus the integral of v du. Okay, so we already know our u is x and our dv is e to the x dx, so we have that already. So that's going to equal uv, so x e to the x, minus the integral of v, which is e to the x.
You move it up.
Oh, sure. Du, which is dx. So pretty much everything on the right of that equal sign, you're just going to start replacing. Okay, so this just stays x e to the x minus the integral of e to the x is e to the x. Now you just throw in your plus c since you don't have any more steps. Okay, so this is actually your answer. All right. Any questions on this one? All right, leave that up for a few seconds. right. Okay, so what if we wanted to evaluate the integral of secant cube of x dx using integration by parts? Okay, so remember before we couldn't solve that one until we learned integration by parts, so now we're going to solve this one. Okay, so all we have to do is factor out a secant squared. So the integral secant x, secant squared dx. Okay, so for this one, we're going to let our u equal secant of x. And our dv equals secant squared of x dx. Okay. So we know our du is going to be secant x tangent x. And our v is going to be the integral of dv. Which is the integral of secant squared of x. Okay. So our v is going to equal tangent x. Okay, so we have our dv, we have our u, we have our du, and we have our v. Okay, so now you just plug everything in. The integral of u dv, which is just our secant and secant squared, equals uv minus the integral of v du. Okay, so that's going to equal uv, which is secant x tangent x, minus, move that up some, the integral of v du, which is secant x tangent x. Oops, should be a dx right there. Excuse me. All right, so we can go ahead and just combine those two. Minus tangent square x secant x with respect to x. Okay. Now for this one, we can notice that even in positive exponent. Which means we're going to replace that with secant squared x minus 1. Move that up a little bit. Secant x tangent x minus the integral secant squared x minus 1 times secant x dx. Excuse me. Okay, now we just go ahead and distribute that secant x. Yep, actually let me write so it won't get lost in the shuffle. We're still going with the integral of secant cube x equals secant x tangent x minus the integral of secant cube x dx plus secant x. Oh, minus, yep, plus.
Minus secant x. Or no, oh no, minus.
Yep, the minus and the negative. All right, so we know the integral of secant x is natural log of secant x tangent x. So the integral secant cube of x dx equals secant x tangent x minus the integral of secant cube of x dx plus the natural log of secant of x plus tangent of x. Plus c. All right, now what looks odd?
You have
We're
to
right at the
insert
start
into the
again.
equation.
Yep, we're right back to the start. So it's possible I'm just sleepy and messed up again. I am a little tired, but I didn't mess up. Ha! So just add that to both sides. That's all. I know you're like, you messed up again. I knew. Yep, you just add it to both sides. So if we add the integral of secant x dx plus the integral of secant cube x dx, now that disappears. So actually this does have a reason why it popped up again. Okay, so now we have 2. Integral of secant cube of x. Oh, move that up some. Dx equals secant x tangent x plus the natural log of secant x plus tangent x plus c. So now we're like one step away. So all you have to do is divide by 2. So you divide by 2. Oh, move that up some. Okay, the integral of secant cube of x dx is going to equal 1/2 secant x tangent x plus 1/2 natural log of secant x plus tangent x plus c. And that is actually your answer. So even though it looks like it kind of took a step back, it was actually meant to happen. So once you add it to both sides, then divide by 2, that's how you solve it. And you'll see that with secant with odd exponents more often than any others. So if you happen to see one and it pops back up again, you'll know it's supposed to. All right, so any questions on that one? All right, I'll leave that up for a few seconds. Let everyone get finished writing. And that's about to shut off. I might as well restart it. All right. Move on to the next example. Might as well